Hello, AP Calculus folks. Back to the videos for tricky substitution problems. Well, these aren't really tricky substitutions. These are just like, it's just reviewing substitution method. And one of the things you have to look for on this test is whenever you see a video that, or a video, whenever you see a question that has a complicated integral, you either have to try to simplify the integrand or you have to think about substitution, for at least for AB calculus. For BC calculus, there are other techniques for integration, but for AB calculus, there's basically like a substitution method is our primary method of getting through tricky integrals. So when we look at this integral right here, if it was just the integral of e to the u or e to the x, we'd be able to integrate it. But clearly we have an inner function, so we're going to make a u substitution, just like we did when we did the chain rule. In fact, um, substitution method is the method for reversing the chain rule from differentiation. For those of you who like to think about it as like differential calculus and integral calculus as inverses of each other, I mean, they are, but this is the process for going backwards. So we're going to make a u substitution. U equals root x, and then du equals 1 over 2 root x dx. Remember what we talked about with substitution, that you want to make the solve for dx. So when you solve for dx, because that's what you're going to substitute back in, you're going to have 2 root x times du. So now we take this integral, we're going to reshape that integral. It was e to the root x over root x dx. We're going to replace the integrand. We have e to the u, okay, because that's substitution. The root x we have it's over root x, and the dx we're going to replace with 2 root x du. So we've made that change with that part, and now you should see that the x terms cancel. The 2 will come outside the integral. You're just integrating a nice simple case of e to the u, and then when we integrate that, we get e to the u again multiplied by 2 plus a constant. We have to replace our substitution, 2e to the root x plus c, and now I am looking for 2e to the root x plus c. That would be choice A. Sometimes they have us actually change the limits of the integral, and they don't want to see the answer to these integrals. They want to see what the new integral would be with the u substitution. So hopefully we have one of those to show you. But our next problem, what I'd like you to do is just do a quick substitution method. I'm going to pause the video, let you guys figure out the answer, and then I'll show you the solution. Okay, so we're back, and in this case, our u substitution is 3x. Our du is equal to 3 dx. We solve for dx, and we get 1/3 of du, and then we just rewrite that integral cosine of u. The dx term is replaced by 1/3 du. The 1/3 comes out in front. I'm just integrating a nice easy cosine function, which is going to be the sine function. Remember to have your derivative of sine and cosine squared away so you don't make the mistake with the negative. So this is 3x plus a constant. You can always check this integral by taking the derivative of it. And when you take the derivative of sine of 3x, you've got the chain rule going on, which will be 1/3 cosine of 3x times 3. The 1/3 and the 3's cancel, and we're back at where we started. But this should be the answer to choice C would be our answer. So hopefully that helped. And then now we have a function. We're trying to find an average value of a function. So this requires a couple things. You have to remember what average value means. Remember, average value is finding the area under a function and dividing by, if you're integrating from a to b, the width of the integral. This is not average rate of change of a function. This is average value of a function. Give this one a shot. You're going to need a little substitution to help you out with that. And then when I come back, we'll go over the solution. Okay, well, we're back, and let's set up the integral. Remember, it's the average value from 0 to 2. We're going to integrate x cubed x to the 4th plus 9 dx. It's going to be all over 2 because the width of the integral is from 0 to 2. So to do the top portion, we need to do a substitution method. So u is going to equal x to the fourth plus 9. Du is going to equal 4x cubed dx. When you solve for dx, you can get du with 1 over 4x cubed in front. So we need to replace our integral. I'm going to change the limits of the integral as well. So because this is a part that I'm trying to figure out as far as what the area under that curve is. So if I switch over to the u domain, I'm going to completely switch over to it. So I'm going to have x cubed. I'm going to have the root of u for my substitution. The dx will be replaced with 1 over 4x cubed du. And then these x cubes cancel. My limits will change from, I have 0, so when I put 0 into x, I have 9 at the bottom, and when I put 2 into x, I have 16 plus 9, that would be 25. That was really nice. And I'm still dividing by 2. So let me clean up this integral, because we just don't want to make a silly mistake because of not being neat. So we're going to integrate root u du from 9 to 25, divide it by 2. Some people would change this to 1/8 right now, so we don't have to worry about that fraction out in front. The antiderivative of u to the 1/2 is u to the 3/2 times 2/3. How do I know it's 2/3? Well, from when you divide by a fraction, you multiply by the reciprocal, and I'm going to evaluate this from 9 to 25. So now here's a trick that, we have. This is 1 over 12. That's not the trick. That's just fractions. So we're going to have 25 to the 3/2 power minus 9 to the 3/2 power. A lot of kids in class, they have trouble doing this without a calculator, but you have to remember, do the root first. The root first of 25 is 5, and then cube it, and you get 125. On the next one, you do the root first, you get 3, then cube it, you get 27. So I have 1/12 of the difference of 25, 125 minus 27, which I think is 98 over 12, and so that might be 49 over 6. I hope that's correct. Let's look at the choices. Thank goodness I have 49 over 6. I would definitely double check my work here on the AP test because I don't want to make a silly mistake. I think this one is a mistake if I forgot to divide by 2 and find the average value. I think this is a mistake if you just did the first part. 98 over 3 is also if you did not have the 1/4 out in front. So there are all a bunch of problems that you could have made based on little arithmetic mistakes. So please be careful with this problem. And hopefully this video has helped you understand or review at least a little bit of the chain rule, and we saw a problem with average value. Please let me know in class or comment on this video if this was helpful.